Well, hello, my lovely 6th grade students. We are going to do our next graph, which would be our box plot, also known as box and whiskers plot. We have our essential question: how do you make and read a box plot? And why is it important, again, to carefully evaluate graphs? All right, to start, we're going to answer the question, what is a box plot? Now, a box plot or a box and whiskers plot is a number line, uses a number line to show the distribution. So we're talking about how far the data is spread apart of a set of data by using the median, the extremes, and the quartiles. Oops. So each one of those parts is illustrated on the box plot. So for example, we have our lower extreme here, and we have our, I gotta change this, spelled that wrong. There we go. And we have our upper extreme here. Now next we have our quartile 1. The end of quartile 1 starts at where the box starts, and the end of quartile 3 starts where the box ends. Now this vertical line inside the box is going to tell you the median, so that middle point of the data. So all of that can be easily spotted using a box and whiskers plot or box plot. Now this asterisk we use anytime we have an outlier. So whenever you have an outlier, you're going to use an asterisk for that. All right, now what are the steps to making a box plot? Well, lucky for us, we already know how to find the median, so the middle number of a set of data. We also know how to find the quartile 1, quartile 3, and any outliers. So we're just going to use the steps we've already learned, to help us make our box plot. So first step would be to order the numbers from least to greatest. Then you're going to draw a number line that covers the range, because we want to be able to include each number on our box plot. From there, step 2 would be then to find the median. So now that we have them ordered, we can easily find the median. Then we're going to also find the extremes. So we're going to find the extremes, and then finally we're going to find the first and third quartiles. Now by doing that, when we find that information, we're going to simply mark it where it appears on the number line. So we're going to mark each of those spots with a dot. From there, next is the easy part. All the hard work is already done. We're going to connect the first and the third quartile with a box. That's going to represent the middle half of the data. So the middle half of the data. And then we're going to draw a line at the extremes. Yeah. Oh, no, actually, right there we want to draw the line for the median. So let's go back and fix that. We want to draw a line at the median. So that would be inside the box. The rest of step 3 would then be to connect the extremes with a whisker and then mark any outliers. It is really that simple. So now we have 2 examples we're going to do to practice. The first one is going to be points scored for 11 games. So we have our list of numbers here. First step would be, of course, to order our numbers from least to greatest. So I see my smallest number would be 6, and my largest number is 14, so I'm just going to mark all those off. So putting the numbers in order. So I have a 6, followed by a 7, then a 9. That 9 is followed by 10. Then it looks like I have 3. Yep, 3 11, so I'm going to mark those down 3 times. Next comes 2 12s, yes. So just ordering them from least to greatest. Then I have a 13 and a 14. So there are 5, 9, 10, 11, and 11 there, so I didn't lose any. Perfect. So now we just go about doing what we've practiced before, finding that middle number. So we cross it off, small, big, small, big, small, big, all the way till we found that middle number, 11. So our median is at 11. I'm going to put a dot there. So that's my median, my middle number. Next, I'm going to look at the bottom half of the data, and I'm going to find quartile 1, which would be the median of this section, the bottom half. So that middle number is small, big, small, big. What's left in the middle? 9. So quartile 1 is at 9. I'm going to do the same thing for the top half of my data. So small, big, brings me to 12 for quartile 3. So I put my dot there. And then I can mark my extremes. I have my smallest number here is 6. And they're all pretty close together, grouped together, so I don't expect to have any outliers. So I'm going to put a mark at 14. And now all I have to do is connect it so you can see the actual box and whiskers. All right, so step 3, we take quartile 1, connect it with quartile 3. That's what forms our box. So this is the middle half of our numbers. The middle half of our numbers fall in this area. Next, we draw the vertical line to identify our median. So our median is 11, so we have a line there at 11. We're going to connect with our whiskers our extremes, and we have our box and whiskers chart drawn. It is that simple. Now, if we were going to describe this, we could say, of course, that the median is 11, the quartile 1 is at 9, quartile 3 is at 12, our IQR, so our interquartile range would be the difference between 12 and 9, so the interquartile range is 3. We could say, if we were going to look for any outliers, we know we take our interquartile range 3, multiply by 1.5. That is going to get us 4.5. And we take 3 and subtract 4.5 from that. Add, so correction, I'm sorry, not 3. So we take 9, subtract 4.5 from that. That would bring us over in the 5 area. Will bring us to 4.5, and this 6 is not outside of that. Then we take the 12, add 4.5 to that. That would bring us to 14.5, and 14 is not outside of that, so there's no outlier. So remember, you take this outlier, and you would have done the math. You would have done 9 minus 4.5, that would have given you 4.5. There's nothing lower than that. And then you would have taken 12, added 4.5. That would have brought you to, oh, I was off, 16.5. There's nothing higher than that. So you see there's no outlier. And then we could say, well, the bottom half of the data seems to be more spread out than the top half. And it looks like, indeed, our median is closer to quartile 3 than it is to quartile 1. Those are all some of the terms we could use to describe it. All right, we're going to try it again with example 2. All right, example 2 are laps completed for a walkathon. So we had 8 kids who participated in the walkathon. We counted all of their laps, and now we're going to look at how that information is distributed, so spread out. All right, again, the first step would be to order our numbers. So I can see I have a 2, followed by a 4, then we have 6, and there are 2 of those, so I copy it down twice. Next number would be 8, then 11, 13, and then 24. Now looking at this so far, I have numbers in the teens and then in between 0 and 10, but I don't have any other numbers inside of their 20s. So right now in my brain I'm thinking, 24 might be an outlier. So I'm going to definitely pay attention to that, just in case. All right, so we have them ordered. Now we need to find our middle number. So marking off, small, big, small, big, small, big. And because this is an even set of numbers in our data, we do end up with 2 in the middle. And we know the process to find that median. We're looking for the number halfway between. And I know in your brain you're saying, hey, halfway between 6 and 8 is 7. So that would be our median. But again, if you didn't know that, you would take 6, add 8 to it, you get 14, then you divide it by 2, and that would get you, of course, that median 7, if you couldn't see it easily. Now from here, because our median is 7, we're going to look at the bottom half, which includes these 6s, and we're looking for what's that number. So small, big, and we have 2 in the middle. So we're looking for quartile 1, we're looking for that middle number. Halfway between 4 and 6 is 5. So let me back it up just a little bit. Let's mark our median 7 right here. And now we know quartile 1 is 5, so it's here. Now let's go find quartile 3, so the top half, that middle point. So we have small, big, and 2 in the middle. So halfway between 11 and 13 would be 12 for quartile 3. So quartile 3 is here at 12. And now again, I said 24. I can already see that's the only number I have in the 20s. Everything else is, well, basically less than 15. So I need to know if I have any outliers, because I want to mark those with an asterisk. So I'm going to need our interquartile range for that. So taking 12 minus 5, quartile 1, and I get a difference of 7. So now that I know my interquartile range is 7, I do 7 times 1.5. That gives me 10.5. So of course you can use your calculator for that. So now I'm looking to see, do I have any number? So when I take my lower side, which is in this case 5, when I do 5 minus 10.5, I'm going to get a negative 5.5. Is there any number smaller than that in my list? No. We have all positive numbers, so there's no outlier on that end. Then I'm going to look for the other one. So quartile 3 ended at 12, so I'm going to do 12 plus this 10.5. 12 plus 10.5 brings me to 22.5. Do I have any number greater than that? And I do. It's 24. So indeed, this 24 is an outlier. So I don't mark it with a dot as my extreme. Because it's an outlier, I put it as an asterisk. Now, what do I put the extreme at on that side? Well, the extreme is going to be the next largest number. My next largest number was 13, so I'm going to put a dot at 13. And my smallest number, 2, I'm going to put a dot there. So now that we have these spots marked off, now we can form our box and whiskers. Taking quartile 1 and quartile 3, we connect the box. That forms our box. So the 50%, the middle 50%, the middle half of our data. I have my dot where the median is, so I make that vertical line there. I'm going to draw my whiskers. And then I already have my outlier marked. And that is how we draw a box and whiskers plot. All right, see you in video 2 to get practice analyzing.